Yo, what is up guys? I'm Sam here. In this tutorial, we're going to create our first application using the Rust programming language. I'm following along with the Rust book, and this game is from the Rust book itself. Let me show you how it works. Um, Name is guessing game. When you run this game, it will show you some messages and ask you to input a number. For example, I input 10, and it will show me a message which indicates that this number is how close to a secret number. So, for example, when it says too small, it means the 10 is smaller than the secret number. So, uh, I input some more numbers to find the secret number, and the secret number is between 1 and 100. So you can see here, I guessed it right, and the secret number was 90. So that's it. We can now create our project. For the sake of demonstration, I will show you how you can use the cargo to create our project, but we can use our IDE or text editor to create the project. But in this tutorial, we are going to create uh, the project using the cargo. So you can see here our project is created, a guessing game, and there is our main file and cargo tumble file. So let me open up CLion, and we can go to our project here and open up our project. Okay, so we can here we can see our main file and our tumble file to manage our dependencies. Uh, Simply we can press this button and run our program. So first thing that we do is we want to uh, get a number from our user, and we can do this from the terminal using the standard library of Rust. By default, when we create our Rust file, uh, Rust compiler will preload some libraries into our program. So, for example, this print line is comes from that prelude. But for other things that we need to import those libraries. If those libraries are from the Rust standard library, we are good to go. We can simply include them and use them. But if those includes are from other packages that are not included in the Rust standard library, we need to add those dependencies here and then include them in our source code. We will see how we can do that in a sec. So we're gonna to import the IO, which we use to get input from our user. Here we show a message to user, guess the number, and we say please input your guess. So we want a variable to keep the guess of user and handle it later and compare it to our secret number. But for now, we are just going simple first and just get the guess from the user to see how we can match it. Generally, there are two ways to define variables in Rust. One is mutable and another one is immutable. Immutable variables are uh, indicated by the let keyword. For example, we can create a variable called apple using the let keyword. this variable is immutable. We cannot change its value. For example, I cannot assign another number to this variable. You can see here uh, the error message indicated that we can't modify the value of this variable. So this code is not valid. If we run our project, you can see we get some errors here saying that we are assigning to an immutable variable. So if we want to change the value of a variable, we need to mark it as a mutable variable with this mut keyword. So after that, we can change the type value of the variable. You can see now our code is working. So let's change the name of the variable to yes, and this variable should be a string because we are getting string from the uh, inputs of our terminal. So in Rust, we create a string like this, and it will initialize our variable with an empty string. So here we're going to get something from the terminal, in fact from the user. So to do that, we can use the std in, means std input, standard input, and there's a function called readline, and this function waits for an input from the user and passes that input to the variable that we pass through it. So we can pass our string like that, and you can see here we marked it as a mutable reference. So it will pass a reference of a mutable reference of our variable to this function. This may be a little bit complicated for now, but bear with me. We're going to deep dive into this type of things in the future. So when we get this variable from our user, we will use this function here. But you can see, if let me add a semicolon here, you can see the result of this function is a type of result which contains usize and error. So in a successful operation, it will pass us a usize variable, but in error operation, it will return us an error. And you can see here we are getting a little bit of warning here. If you can see, our compilation has some warning that it says our code maybe throw an error that is not handled. So to handle this error, we can use the expect function. This expect function panics with an error message that we're passing to it. The panic is some kind of error situation in the Rust that, again, bear with me, we will get back to it later. So for now, I just go with a message of fail to read line. And don't forget the semicolon here. So now you can see our project is not showing us a warning anymore. So for now, we are getting the input of our user and saving this input to this variable. Let's show this to our user. If we use the print line function, we can place this variable inside the print output. So let me write you yes. And here, if I use the curly braces, you can pass a name of a variable, and the Rust compiler replace this variable value in this section. So let's restart our project. Here it says please input your guess, and this input, you can see the cursor here, this input comes from this line. So our code is now in this line and it's waiting for us. I input 10. Now you can see showed up here with the value that we set to this variable. So if I run it again and add another number, for example 20, you can see the variable is now changed here. Another way of doing this is to use placeholders. Instead of passing the name of a variable here, we can simply place an empty curly braces here. And as an argument, we can pass the value of this placeholder. So let me run again, and you can see our code is run exactly like before. So we get a value from user successfully, but we need to create a secret number to match that value with the secret number. To generate a secret number, we can use external libraries. Those libraries can easily create a random number for us. A popular package to do this is the rand package. You can find this package in the cargo package website. We're gonna take a look at that in a moment. So you can see here the CLion autocomplicity version for me. The last available version is here. So when I add the rand here, you can use this library in your code. But let me open up a terminal here and build our project using the cargo. Now you can see it's updating index, and here it adds some external libraries for us like libc, getrandom, and etc. So these are requirements for our rand package. And if you go to the log file here, this log file is automatically generated by cargo, and you should not modify it. But if you go here, you can see some versions and some packages that are dependencies of other packages that we are added. You can see here the rand package contains some other dependencies, and each of these dependencies have their own dependencies. So this log file manages the version of these dependencies and makes sure that our project is using the exact same version for all its libraries. But now if I build again, you can see cargo build, it finishes immediately because those packages are downloaded in the first place. And that's fairly simple. Imagine if this package got a new major release, for example 090, we can simply change the version and build our project again. But at the moment there is no version of 09. So let's back to our previous version, and let me show you the cargo packages website here. Here you can search all the available package in the cargo. For example, if I search for round, you can see our round package is here, and along with some description and documentation and etc. So basically all of the cargo packages are available in this website, and you can search for them. Okay, now that we successfully added the rand package to our project, we can use it to create a random number in the range that we wanted. So we should use rand rng here, and for example after this line I created an immutable variable because this number will not change in the future. So I simply create an immutable variable to keep the number in it. So by using thread RNG and get range, we can get a number, get a random number between 1 and 100. And you can see here some weird stuff here that contains two dots and an equal sign. This is the range expression in Rust. So by using it, you can define a range. But if you're curious how I know to use this function, uh, how do I know that there's a thread RNG or get range? These are comes from the documentation of the RAN package, which we'll look at in a moment. So here we created a random number in the range of 1 and 100. So for example, it could be 40 or 9, anything. And there is a cargo command that is cargo doc. If you pass the open option, it will create the documentation of all your packages, including your application and other packages that you are added to your project. For example, the name of our application is guessing game. You can see here there is no documentation for it, so it's created an empty documentation for our only function, that is the main function. But if you take a look at here, you can find the rand package, and here you can see it describes how to use this package, and content of this package are here. For example, module structs and traits, functions, anything is here. You can click on them and see the documentation of those components. So this is comes in handy, and this documentation is offline. You can view it when you are offline. So that's kind of cool. Now let's keep going and compare our guess to the secret number that we generated using the RAND package. So we can use a match expression to match our guess with the secret number. We can use the match like this. This may be completely new to you. That's okay. We're going to have a lot of fun with the match command, but for now, bear with me and follow along. So in the string variables, there is a CMP function that will compare this variable with another variable, and the output of this CMP function is ordering, which we can use that ordering against the match expression to find the result of our compare. So if ordering is less, it means the variable is less than the other, and if it's greater, it means the variable is bigger than the other variable, and if it's equal, it means variables are the same. So let's run this project and see what happens. uh, as you can see, oops, looks like there is some mistake here, so let's figure that out. Sorry, my bad. This is gen range, not the get range. So as you can see, that first error is gone now, but there is another error here that indicated it requires another string here, but it got an integer. So why is that happening is because guess is a string. You can here see there is a string here. Guess is a string and secret number is integer. So those type are not matched, and the compare method of guess only works with another string. which in this case we're passing another number. So how we can overcome this issue? We can change the type of guess back to integer. So both of these variables will be integer, and we can compare them. And the good news is the CMP function is available in the integers as well. So when we get our variable from the user, we can redefine it. In Rust, you can define a variable again with the same name. Uh, so we can redefine it with the type of u32, which indicates that's an integer variable. And here we can change the type of guess back to integer, and we can use the parse function for that. So first we need to trim that. Trim will remove the white spaces from the both side of the string. For example, if you input something like this, both white spaces will be removed from the sides. And here we use the parse function to change the value of this string to an integer. And like the read line, the parse option will also returns a result that we can use the expect function to show an error message if the parse operation fails. So the parse operation will fail if the input is not a number. For example, if user put some letters in the terminal input, the code will be panicked here, and this error message will be shown to the user. So here you can see we are now redefine the guess, and the guess is now an integer, and we can compare it to the secret number. Now you can see we need to input, and it worked, and you can see the number is too small. So the secret number is something higher than the 10. But as you can see here, our process is finished, and our program is no longer running. We need to fix that. So to fix that, we can uh, go and put all of our code in an infinite loop. There is a command for loop, and you can see how it looks. And everything you put inside this loop, it will run it forever. So I grab all of this code and place it exactly inside the loop. So you can see here everything is now inside the loop. So let's run it again. For example, 10, too small, 30. Okay, 30 is too big. 25, 26, 27. Oops, I accidentally pressed the enter button. You can here see that there is empty space. I accidentally pressed the enter button, and it panicked at this moment. We will fix that in a second, but just let me show you something else. We can print our secret number here, and now if I run our program, the secret number will be printed, and then we go to our loop. So here you can see our secret number is 56, and if I, for example, put 50, you can see it's too small. If I put 60, it's too big, and 56 is the correct number. But we have two problems here. One is, although I put the correct number here, but it asked me about my guess again. I can put another number here. We need to close our app when the correct answer is guessed. And if I put something other than a number, for example, um, put some characters here, uh, the app will be panicked and it will be crashed. We can fix those issues now. So quitting the app is easy. When we are here, we need to get out of loop and finish the app. To do that, we need to add curly braces here and add our print back. And here we need to break from the loop and add another semicolon here. So if I place the 95 here, you can see now it's quit from the app. So that was easy. And for the panic problem, we need to continue the code when the input of user is invalid. So we need to add some changes here. As I said before, the parse function returns a result. The left side that indicates everything is well, and another is the right side that indicates we had problems. We can use a simple form of match expression here. If here I simply add curly braces and put a match here, you can see we can now match against the results of parse. On the left side, we will get an OK result with a number passed as the parameter. So in this situation, simply we just return the number, and in case of error, we don't need the pass parameter, and only we want to continue and get out of the loop. So basically here we ignoring our error and just continue the code if there is a problem, and we go back to the first place of the loop to run our loop again. So let me run the project. If I place a number here, for example 10, it works. If I place some characters here, you can see it ignores the error and returns back to the first of the loop. And we can find the number is 20, and if I put 20, we got the message and get out of that. But I will comment this section here, so we don't know the number and we can play the fair game and find the secret number using our app. Let me find it: 70, 80, 90, 100, 2 big, 95, 96, 97, 98. Yeah, that's it. The number was almost at the end of the range. So this is our first project in the Rust programming language, fairly simple project. I will put this project in the GitHub and place the link in the description. I hope you enjoyed this video. Please consider liking and subscribing because that motivates us to create new videos for you. I see you in the next one.